Hello, today we're going to learn about dilations and dilations in the coordinate plane and specifically centered at the origin for today. So first of all, it's important to note what a dilation is. A dilation will produce an image that is similar but not congruent. Thus, a dilation is not a rigid motion. Dilations can create figures that are that will be similar because they'll either be reduced or enlarged from your original figure. So if we remember correctly, when we have two figures, the one with the primes is your image, and the ones without the primes is your pre-image. So here, this is my image, and then this is my pre-image. And when you're talking about this, notice that the pre-image is larger than what the image is. So that means this has had a scale factor of a reduction. So there can either be an enlargement of the figure or a reduction of the figure. And based on the scale factor, that is how you determine if it's an enlargement or a reduction. So the scale factor is generally represented by the letter K, as you can see here. So the K represents your scale factor, and a scale factor is a ratio of the image over its pre-image. So for example, if there was a K of 3. That would mean that the image would be getting larger when K is bigger than 1. It makes the figure larger, so this would be considered an enlargement. If K falls between 0 and 1, so for example, if K was like a half, that would be a fraction between 0 and 1, and that is going to produce a reduction of an image. So the image will get smaller, as in our example over to the left. If K is equal to 1, then the image will stay the same, because that will create an image that is going to be congruent. Think about if you multiplied anything by 1, it would remain the same on there. If K is less than 1, that's a fun situation. If K is less than -1, what happens is it's actually an enlargement, and it's also a reflection because the image will be flipped from its original. We won't study those too often. So when you're using your notation for dilation, it's important to note that the dilation must have a center and a scale factor. So when finding the center of dilation, it's quite simple actually. You can take and draw lines connecting the pre-image to its image vertices that correspond to each other. So if I just took like a straight edge and connected from C to C prime, and did the same idea from B to B prime, the intersection of all of those lines or segments that connected together would create the center of dilation. So here I'm just going to label this. I'm going to call it R for this case for fun. And I'm going to say that this is my center of dilation. So if I were to write this with proper notation, the D again is going to represent dilation. So I go D, and then my center, in this case I use the letter R, and this might have a scale factor of a half since it's getting smaller on there. So it's half the size of the original. The image over the pre-image is your scale factor. Another way I like to think of scale factor is this. It's N over O, your new image over your original image. So NO, new over your original on there. Okay, let's pause and do some examples.